So next topic that we have is priority scheduling algorithm. Okay. Okay. Now, as the name says here, the word priority means same thing. Suppose if we take the same processes, let us assume that we are having 3 or 4 processes. Okay, those all 3 or 4 processes, they are going to work based on priorities. Suppose if we take the previous example, we were having some processes like P1, P2, P3. So all these processes were working based on something like brush time. So along with the brush time, we are going to have one more column over here, which is called as priorities, priority of the process. Okay. So it is going to be something like this. Suppose we take the processes and the brush time. Let us say 4 or 5 processes. P4, P5. Sorry. Let us say we are having 5 processes. So first process, brush time is 10, we'll take the same values. For fourth process, we'll take some brush time of about 6. And for the fifth process, we'll take some brush time of about 4. So these are the brush times of every process. Along with the brush times, we are going to have one more column over here called as priority. We are going to have one more column called as priority. Okay, what is this priority exactly? That is, every process, how much priority will be given. So it can be any number, it can be any numerical number. It can be once again any numerical number indicating the term. So we'll take the numerical numbers from 1 to 5. So let us say that process P1 is having the priority like 3. Process P2 is having the priority 4. Process P3 is having the priority 1. Process P4 is having the priority uh, 2. And process P5 is having the priority 5. Let us assume these are the priorities. So previously, in the previous 2 algorithms, what it was doing is, it was doing the things based on how the things are. Like if we come to the first one, as the processes are coming in P1, P2, P3, it is going to execute in the same order. Suppose we come to the shortest job first, it is going to take the shortest job and is going to execute the things. Whereas if we come to the priority scheduling, it is going to take the things based on priorities. That's how it is going to execute the things. So if we take the diagram of the thing, we'll take this diagram. So first, if we take the order of execution, I hope everybody is able to follow this. Everybody is able to follow me, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. So if we take first the order of execution, what is the order of execution? Which is the first one which is given the priority?
P3.
P3 is the first one which is given the priority, followed by
P4.
P4, followed by
P1.
P1, followed by
P2.
P,
2.
2, followed by
P5.
P5. This is the order of execution of the priorities. Okay, so order of execution will be first priority is going to P3, followed by P4, followed by P1, followed by P2, followed by P1. So because based on the priority, this is how it is going to do the things. So if we classify the things in the same way, okay. Now, so order of execution will be first P3, followed by P4, followed by P1, okay, followed by P2, followed by P5. So order of execution will be like this. Clear? Clear, Matilia?
Yes, sir.
Now we'll take the values. As the first priority is given to P3, how much time it is going to execute? The things are going to start at 0th second. Things are going to start at 0th millisecond, right? Things are going to start at 0th millisecond. So as P3 is going to take how much burst time? 3
3.
milliseconds. So from 0 to 3, P3 is going to execute. Then at 3 milliseconds, P4 is going to start executing. Then P4, how much time it is going to take? How much time is P4?
6.
6 milliseconds. So 3 plus 6?
9.
9 milliseconds. Up to 9 milliseconds, P4 is going to execute the things. Then at 9th millisecond, P1 is going to start the process. Then P1, how much time it is going to take?
10.
10 milliseconds.
10.
So 9 plus 10?
19.
19 milliseconds. P4 is going to do the things. P4 is going to do the things up to 19 milliseconds. At 19th millisecond, P2 is going to start the things. Then P2, how many milliseconds?
3.
3 milliseconds. So 19 plus 3? 20?
22.
Sorry, 22. Then at 22nd millisecond, P5 is going to start the things. And P5, when it is going to, how much time is going to take?
4.
So 22 plus 4?
26.
The total time taken is going to be 26 milliseconds. Clear with this, everybody?
Yes.
Able to follow, ma? All are
Yes, sir.
able to follow this till here? Yes? No?
Yes, sir.
Fine, okay. So next what we have is total duration and waiting time. We're going to calculate total duration. Total duration is already, we know it is 26 milliseconds. Right? Excuse. Total duration is going to be 26 milliseconds.
That
26
will come as a tourist.
milliseconds. So That is done. Then next, what we must have? We must calculate average waiting time. So in order to calculate the average waiting time, first we must know what are the waiting time of all the processes. We must know the waiting time of all the processes. So if we take the waiting time of all the processes,
But it's not QCF fault also, right? It is not a QCF fault. QCF fault.
just mute and talk, ma. Don't talk in the.
QCF.
Who is this? Aniruddha?
Abhishek, sir.
Abhishek.
Yes.
Abhishek, mute. So suppose we take the process P1. What is the waiting time of process P1? P1 has started at after P4. So it has waited for P3 and P4. So it has waited till 9 milliseconds. Right? P1 has waited for 9 milliseconds. Then if you take P2, how much time it has waited? How much time it has waited? It has waited for P3, P4 and P1. Yes? So how much time P4 has waited for?
19.
19 milliseconds. Right? Then next is P3. P3, how much time it has waited? 0 milliseconds. Then next is P4. P4, how much time it has waited?
3.
3.
3 milliseconds. Then next is P5. P5, how much time it has waited?
22.
22
22.
So these are the waiting times of all the processes. Clear? Followed this, everybody?
Yes, sir.
Now,
Yes, sir.
if we calculate the average waiting time, if you're able to calculate the average waiting time, okay, that is average waiting time is we need to calculate the total of all the things. That is, P1 is 9 plus P2 is 19 plus P3 is 0 plus P4 is 3 plus P5 is 22. How much is the total? Can anybody calculate and tell me the total?
53.
50?
3.
Sure?
Yes, sir.
Divided by how many processes are there?
5.
So, what is the average waiting time? 10.6.
0.6.
10.6.
Right? Am I right?
Yes,
Yes,
sir.
Yes, sir.
Yes, sir.
So, average waiting time of this algorithm is going to be 10.6. Hope everybody have followed this.
Yes, sir.
Yes, sir.
But here, when we come to this scheduling, actually there are some advantages as well as there are some disadvantages using priority scheduling. Okay, we'll see what are those advantages and what are those disadvantages using this. First one is when we take the priority scheduling. Every process, every process must have something called as process number. Okay, there's a foremost thing. Without the process number, we cannot do the things on. Okay, every process must have something like process number. If a process is not having a process number, it cannot take the things. It must have both the brush time as well as it must have the priority number as well. If the priority number is not given, it cannot work under this. There is a first thing. Second thing is the CPU, that is whatever we take, will be working from highest priority to the lowest priority. Okay, the CPU is going to work from highest priority process to lowest priority process. Then next thing is it can work It can work for both preemptive and non-preemptive processes. Both the things are going to be supported. Preemptive process is going to be supported, as well as non-preemptive process is also going to be supported for priority scheduling algorithms. These are the something like advantage for the things. But if we take this, if we take exactly the priority scheduling, when we take the priority, it is almost indicating a different thing. Like if we compare it with the shortest job first, here the priority is inverse of predicted to the next CPU burst time. So we cannot say that if the job is shortest, it will take first. It doesn't mean so. It is going to be completely inverse of the things. That is the main thing we need to understand over here. But if we come to one major problem, in this, we have one problem called as starvation. If you remember, I've said the word starvation earlier. Anybody remember the word starvation? What is starvation exactly? Anybody remember this term? Okay, I'll tell you. Starvation is nothing but here what happens if we come back to the example. I'm having 5 processes P1, P2, P3, P4, P5. P5 is executed at the last. Suppose if we take the order of priorities, this is the order of priorities. Suppose P1 is having highest priority, it is executed first. Sorry, P3 is having highest priority, it is executed first. Then P4 is having next priority, it is going to execute next. By the time P4 has completed, let us assume there are 5 more processes which have come up. Okay, so P1 has to start, or P2 has to start with the priority 4. P2 or any other has to start with the priority 4. But before P4 starts, another process have come, another 3 or 4 processes have come with a priority 1 or 2. Okay, P2 is having a priority 4. Remember, P2 is having a priority 4. So before P4, the priority 4 process executes, there are 4 or 5 processes which have come up, which is having the priority 1 or 2. So which one is executed first? Is P2 executed first, or the priorities which are having either highest priority will be executed first?
Highest priority.
Highest priority. So P2 is kept in waiting once again. P2 is kept in waiting, and the priorities which is having 1 and 2 are executed first. They are going on executing. So P2 is not given a chance. So after completing, again when P2 is supposed to execute, again few more processes have come with highest priority. Again what happens? P2 has to still wait. It is going on waiting to execute the process. So as it is going on executing the process, what is happening over there? It is never going to execute the thing. That is, it is dying of executing. It is eagerly waiting to execute. It is dying to execute the thing. That is what is called as starvation. Normally, if we use the word starvation, we'll be using for the hunger. Starvation is the word we'll be using for hunger. That is, we are dying to eat. So it also is dying to execute the thing. That is what is the meaning of the term starvation. So lowest priority process may never get a chance to execute. That is what is called as starvation. So the solution for starvation, there is a solution for starvation. What is that solution? We'll see that. We have something called as aging. Aging is a solution for starvation. Aging is a solution for starvation. What do you mean by aging? As the time progresses, what it will do is the lowest priorities, that is P2 and P5, as the time progresses, P2 is having priority 4, P5 is having the priority 5. So priorities are going to decrease if new processes have come. P2 priority is 4, and if new processes have come. So what it will do is when new process comes, P2 priority, which is 4, will be reduced to 3. It will be automatically reducing the priority to previous one. So P2, which is having the priority 4, is getting reduced to 3 automatically when a new process comes. Again, a new process comes, P2 priority, which is 3, is getting reduced to 2. So like that, the processes which are waiting also will be getting a chance to execute. That is what we are doing is, if the priorities which are at the last, if they're not getting a chance to execute, what we will be doing is, if a new process comes, the priority which is highest is going to reduce the priority to the lower level. Again, a new process comes, it will be further reduced to the lower level. So that no process will be waiting in the queues for execution. That is what is called as aging. As the time progresses, increases, the priority will be decreased. It will increase the priority of the processes. That is what is called as aging. I hope everybody is clear with these things.
Yes, sir.
All have followed this, ma?
Yes, sir.
Okay, fine.
Yes.
Let me take the attendance first and we'll continue the class.